Welcome back. We come to the third experiment, probability and statistics. We import the libraries NumPy and SciPy. First, we do the mean value implementation. We assign one metric as LL and then we calculate the mean value of all elements. Calculate the mean value by column. The value 0 indicates the column vector. Calculate the mean value by row. The value 1 indicates the row vector. Variance implementation. We prepare one list, B, and one metric, LL. Calculate the variance of B. Calculate the variance of LL. The value of the second parameter is 1, indicating that the variance is calculated by row. Standard deviation implementation. We prepare the data and then calculate the standard deviation. And following, we calculate the covariance and correlation coefficient. Binomial distribution implementation. Recall the main concept. The random variable x, which complies with a binomial distribution, indicates the number of successful times in n times of independent and identically distributed Bernoulli experiments. The success probability of each experiment is p. We import the binom from SciPy statistics and we use this function to build the binomial distribution. The n and p parameters indicate the success times and probability in the binomial formula, respectively. Size indicates the number of sampling times. We check the mean and standard deviation of binomial distribution. And we visualize the distribution by generating a histogram. The bins parameter indicates the number of bars in total. By default, the sum of the percentage of all bars is 1. From the figure, we can see the sample size of 10,000 numbers complies with the binomial distribution. Poisson distribution implementation. Recall the main concept. A random variable x that complies with the Poisson distribution indicates the number of occurrence of an event within a fixed time interval with the lambda parameter. Both the mean value and variance of the random variable x are lambda. Generate 10,000 numbers that comply with the Poisson distribution where the value of lambda is 2. Then we visualize the Poisson distribution. This is generate the grades. Normal distribution. Recall the main concept. The normal distribution is a continuous probability distribution. Its function can obtain a value anywhere on the curve. The normal distribution is described by two parameters, mean and sigma, which indicate the mean value and standard deviation respectively. First, we set the mean to 0 and standard deviation sigma to 1. Then we have the np-arrange function to return evenly spaced values within a given interval from -5 to 5. The step is 0.1. Generate normal distribution that complies with mean and sigma and plot. The following figure shows the distribution. So that's the end of our third experiment of probability and statistics.